Welcome back to another one of my integration examples videos. This video, this is the fifth video in this series. Each video gets increasingly harder, or I just add different techniques in. So some videos may be easier than others, just because I'll be showing you different ways, and those different ways you may or may not already know. But anyway, I'll be doing these three in order, and I hope you enjoy. So we have example 1, which is fx equals 1 minus x on x squared. So, as always, find the integral of both sides. Okay, and I'm going to expand out the top. Well, I'm going to expand it out, and what that means is we'll have 1 minus x squared over x squared dx. And basically, because having it squared means you square the top and you square the bottom. So I'm just, instead of writing it like this, I'm writing it like this to make it seem a bit easier for you to understand my next step. Because my next step is I'm just going to expand out the top. And I've already done that. So it's going to look like 1 minus 2x plus x squared all over x squared dx. And I'm also going to take this denominator and I'm going to split it. So I'm going to, each one of these values will have its own x squared. And that will look like 1 on x squared minus 2x on x squared plus x squared on x squared dx. Okay, for the first one, I'm just going to write it as x to the power of negative 2, because that's just 1 on x squared is the same as x to the power of negative 2. And I'm going to have, you're going to get rid of one of these x's and get rid of one at the bottom. So it's just going to be minus 2x. And over here we just have plus 1, because x squared on x squared is 1. So there's dx at the end. Now we're going to find the integral of each one separately. So, integral of x to the power of negative 2. We add 1 to the power and divide by the new power. So that's going to be x, add 1 to the power, negative 1, on the new power, which is negative 1. And then we're going to plus c, subtract by, we're going to multiply 2 onto everything, because 2 will be the constant. So subtract 2, and then the integral of 1 on x, or x to the power of 1. We add 1 to the power. Oh, I mean, what am I thinking? 1 on x is just ln x plus c. I just had a mind blank for a minute. And then we finish with the 1, which will just be x plus c. And I'll give each one of these a subscript of 1, 2, and 3. Because the integral of 1 is just x plus c. So this will be negative 1 on x, because a negative number on the bottom means the whole fraction's a negative, and the fact that it's 1 to the power of negative 1, x to the power of negative 1, means that if I bring it to the bottom, it'll just be x to the power of 1. And then I'm going to have negative 2 ln x, and then I'm going to have just plus x. And I'm going to write over here, let's say h equals c minus c2, minus 2c2, because this negative 2 will be multiplied onto c2, and then plus c3. And that means I'll have plus h on the end. And that there is our integral. You could rewrite it to make it look a bit neater, which would be you could have h at the front and then 2 ln x take 1 on x plus h, so you don't have a negative at the front, but whatever. Alright, now I'll get on to example 2, which will be fx equals x multiplied by e to the power of negative 2x to the power of 2. Okie dokie. So, find the integral of both sides. Keep in mind that this power to this 2 here is x squared. So that's x squared. And this whole thing is to the power of e. Or e is to the power of all this. Okay? So, I'm going to use integration by substitution. So I'm going to sub u in for negative 2x squared. I'm going to get derivative, which will be, bring the 2 down, negative 4x. If I do rearrange it to get dx on its own, you basically just switch these two around, which will give you du on negative 4x. Now, I'm going to rewrite this function. You get the integral of x, e to the power of u, because we said that all this is equal to u, multiplied by du on negative 4x, because we said that all this is equal to x. All this is equal to dx, and if dx is here, therefore all this can be here to replace it. So I'm going to cancel out the x and the x, which will give us e to the power of u multiplied by du multiplied by the 1 on negative 4, which will bring 1 over negative 4 at the front, or negative 1 on 4. And then the integral of e to the u with respect to u. Okay. So, this isn't too difficult because the integral of e to the u is just e to the u plus c. We multiply this in, we get negative e to the u on 4 minus c on 4. And if we sub in our u value, we have negative e to the power of negative 2x squared on 4 minus, I'm going to write h equals negative c on 4, and so I can just have plus h. Sometimes I'll do this, sometimes I won't, depending on what I feel like I want the ending to look like. But this here is the answer. Now for our third example, third and final. This one won't take too long, and I'll show you why. Or tell you why. fx equals e to the x on x. So we can rewrite that as capital F for the integral of this side, and then we'll do the integrand e to the x on x, and then to dx to signify the integral of this side. And very short and sweet, it just equals capital E, little running I subscript x plus c. This here means the integral of e to the x on x. Just like how the integral of sine x on x is basically an s with a subscript I x. And just like the cosine of x on x, the integral is just a c with a subscript I x plus c. This here, e to the power of x on x, is a capital E with a subscript I x, which means the integral of e on x plus c. Okay, I hope you learnt something from this video, and I hope you had a good day. Or I hope you do have a good day. Thanks for watching.